Alright guys, here we go. We're doing 3.4 numbers 2, 15, and 42. So it's a lot of our velocities and our functions and all that stuff. The absolute most important thing you guys need to know is s of t is a position function, s prime of t equals the velocity function, and s double prime of t equals the derivative of v of t, which equals the acceleration function. Okay, so you guys gotta have this memorized. We're gonna do it forever. I mean, throughout the end of the year. Take derivatives, go this way, and then when we get into integrals, we start at a of t and we go back up to s of t. But then we also need to know how to write functions and all that stuff. So this first one says, write the area A of a circle as a function of the circumference c. So I would start off with just writing everything I know. Area equals pi r squared, and then circumference equals 2 pi r. So this is a circumference in a function of r. This is area as a function of r. So we want area with the variable here being the c. So what we want to do is we want to get rid of that r and replace it with the c. So we come over to this circumference equation. We divide both sides by 2 pi, so those go away. We get r equals c over 2 pi, and now we can replace it in there. So a as a function of c is going to be pi r squared, but instead of r, we're going to put c divided by 2 pi squared. And you can clean that up and say that's pi times c squared divided by 4 pi squared, and then clean it up even more. This pi cancels out with one of those, and we get c squared over 4 pi. So that'd be a good answer for that. Alright, find the IROC of the area with respect to c. So we want to find a prime of c. So in order to do that, we need a of c. A of c equals 1 over 4 pi times c squared. Notice how I rewrote this 4 pi in the denominator as 1 over 4 pi because it makes the derivative easier. The only variable we have in here is c. Pi is not a variable, it's a number. So we just take that, we use the power rule. 2 comes out in front, so we get 2 divided by 4 pi times c to the 2 minus 1, which simplifies to 1 over 2 pi times c, which on a multiple choice, you guys need to know that that and c over 2 pi is the exact same thing. Alright, evaluate the IROC of a at c equals pi and c equals 6 pi. So a prime at pi is going to be c pi over 2 pi, which equals 1/2. And then c equals 6 pi is going to be a prime at pi, 6 pi equals 6 pi over 2 pi, which equals 3. Okay? So if c is measured in inches and a is measured in inches squared, what units would be appropriate for the change in area divided by the change in dc? So the change in the area is measured in inches squared, and then the change in the circumference is measured in inches. Alright. Now, s equals 24t minus 4.9t squared meters in t seconds. How high would the rock go? So this is our position function. Position function is s of t. We want to figure out how high the rock would go. So what's happening in this equation is we're shooting the rock up. It's going to go up to here, and then it's going to come back down here. So our clue to this right here is that right up at the peak of this, our velocity equals 0. So what we want to do is we want to figure out a velocity function. So s of t equals 24t minus 4.9t squared. Remember this, s of t, s prime of t is the velocity. So all we have to do is take the derivative of this. S prime of t equals v of t. The derivative of that is 24 minus 9.8t. That's just using the power rule. Okay, so we're going to take that and we're going to say, when is this velocity 0? 24 minus 9.8t equals 0. Subtract 24, negative 9.8t equals negative 24. Divide by negative 9.8. And we get t equals, I get out my calculator, 24 divided by 9.8. This gives me 2.44 seconds. Okay, 2.44 seconds. So I know my velocity is going to be 0 up to 2.4 seconds. But then I got to go back and read the question. This question says, how high would the rock go? So we have to take our t equals 2.44 seconds and plug it back into our position function. So we got to do s of 2.44, which is 24 times 2.44 minus 4.9. Oh, 2.44. I messed up on that. It's actually 2.449. Okay, look at a calculator. 2.449. Remember the rule. 3 decimal places. I totally forgot the rule. Minus 4.9 times 2.449 squared. So we're just going to use our calculator. And here's a trick I like to use in the calculator. 2.449 is that number right there. So I'm going to go 24 times the answer. That's second negative sign, gives us an answer. Minus 4.9 times the answer squared. Press enter. We get s of 2.449 equals 29.388 meters. Okay, because it says meters in t seconds. Alright. This next one says, find the IROC of f of x equals x squared minus 2x plus 4 at x equals negative 1. So IROC is f prime of x, but in order to do f of x easier, I rewrite this as x squared. This one right here, you want to write as minus 2 times x to the negative 1 plus 4. Now we take the derivative f prime of x, and we're just using the power rule. Some people will use the quotient rule for this one. That makes that problem harder, so don't do that. So we have 2x plus, because negative 1 times 2 is plus 2, x to the negative 2, and then the derivative of 4 is 0. Go back, this is f prime at negative 1, so we do f prime of negative 1, and we get 2 times negative 1 plus 2 times negative 1 to the negative 2. 2 times negative 1 is negative 2. 2 times negative 1 squared, negative 1 squared is 1, so we get plus 2, which is 0. So our answer is C. Alright, thank you guys very much. Hope that helps.